This unit we're going to continue our studying with quadratics, but we're going to start talking about something called factoring quadratics. So we've worked a lot with the graphing quadratic, standard form, vertex form, and factored form. So the last learning target we did was called factored form, and if you remember, it kind of looked, if I can get my pen going here, factored form, remembered, it looked kind of like this, where it had like x minus r1, x minus r2. So this was called factored form. Okay, and this is important because this leads us into our entire unit, which is just a unit on factoring something. Okay, so I want to keep kind of this in our mind, just, keep that in the back of your head as we go into this unit. Okay, so our essential question is, what does it mean to factor an expression with variables? Okay, so when we hear the word factor, we kind of think about, if I have like the number 10 and 5, what are the factors of 10? Well, the factors of 10 are 1, 2, 5, and 10. Factors of 5 are 1 and 5, right? This is what you think when you think of the word factor. Okay, I'm going to kind of change your way of thinking that a little bit today. Okay, so in previous learning targets, we've been using the distributive property to simplify expressions. So let's kind of go back and remember to simplify. So we use the distributive property. In this one, I'm multiplying a times 3a plus 7. So I'm going to distribute that a and get 3a squared, and then distribute the a to 7 and get 7a. In the second one, same thing. I'm multiplying negative 2m times these three things inside to get negative 2m to the third. Remember that when you multiply terms with exponents, you actually add the exponents, so I get to the third. And then I'm going to have negative 12m squared, and then plus 2m. This takes us back to our exponent rules, right? So for this next one, I'm distributing the 4x to the third y to x squared. So I'm going to have 4x to the fifth, and then that y just tags along, and then minus 8x to the third, and then y squared. And then this last one, we can distribute this. You could totally do this if you wanted to. I know some of you do, but I know also a lot of us prefer this box, right? Put the x and the minus 2 here, the 2x and the 4 here, and then we multiply it out. 2x squared, negative 4x, 4x, and negative 8. When I combine like terms, I notice that those cancel out to 0, so I'm left with just the 2x squared and just the minus 8 for my answer here. So this is something that we should be pretty good at, right? If I give you the expression on the left, you should be able to turn it into the expression on the right. Now this unit is all about reversing that process. So what I mean by that is I want you to start in simplest form, meaning that if we take this guy right here, this 2x minus 8, in fact, let's use the first example here. If I give you this is simplest form over here. Over here we call this simplest form. That's simplest form, sorry. Simplest form. And over here, this is all factored form because it's got all those parentheses. I want you to be able to start with this guy, 3a squared plus 7a, and I want you to turn it, create this thing. I want you to go backwards. Okay? So it would be like, if I gave you this 3a squared plus 7a and said, okay, give me a times 3a plus 7. So you'd start here, and this would be your answer. That's what this unit is all about, is how we can go backwards with what we've been doing going forwards. Okay? That's the general idea. There's a lot of ways to do this, and the first way we're going to talk about is the greatest common factor method. So this is a really, really important skill. We call it a gateway skill. Factoring expressions is called a gateway skill because it's really necessary for what we're going to do in algebra the rest of the year. is understanding this concept in this learning target. So before we start with factoring a GCF, I want to be really clear on the two different ways we can use the word factor. So there are two meanings of the word factor. One is a verb and one is a noun. And I don't want you to write this down, but I'm going to write down an example of what I mean by that. So let's look at the word insult. Insult is one of those words in English that can both be a verb and a noun. Don't write this down. I'm just showing something to you. Okay? When I use insult as a verb, I could say something like, she insulted me. Right? And that means that she said something to hurt you, correct? But it can also be used as a noun. You could tell me, oh, she insulted me, and I might say, what was the insult? Right? Like, what did she say exactly as a noun? What was the thing she said? But it can also be a verb saying, oh, she insulted me. She said something bad to me. Okay, so in the same way that insult can be both a verb and a noun, factor can be both a verb and a noun as well. So, you guys are probably used to factoring as the noun. You've seen that a lot in middle school when you guys learned about factors of numbers. So you already know that, right? So I could use factor as a noun saying the factors of 14 are 1, 2, 7, and 14, right? Factors are those numbers that you can multiply to get your original number. So the factors of 14, and I can list them all out, okay? I could also say something like hold on, sorry. Let me get a different color here. I could say something like the greatest common factor of 14 and 21 is 7, right? Because 7 is the highest number that goes into both of them. Okay, so there I'm using the word factors as nouns. So we're going to start learning how to use it as a verb. Okay, so to use it as a verb, I can say something like this. Factor 14 into 2 times 7. Okay? Meaning factor, like break it up into the parts that it's multiplied to. So factor is kind of, and the way I hear the word factor, when I hear the word factor, I kind of think like break it up. Okay, to put it lightly. So factor 14 into 2 times 7. You could also factor 14 into 1 times 14, right? Lots of ways to factor a number. So as we go forward and I start using this language a lot, it's really important to understand what I mean with both of those words, okay? So with all of this stuff done now, all kind of the language part done, I'm going to teach you today the first way to factor an expression, okay? And we call this factoring out a GCF. Okay, so this is a GCF factoring, okay, and this is something that you will have to do almost every single learning target. I'm not kidding, I'm not even like exaggerating. There will be a part in every learning target where you will have to factor out a GCF, okay, so this learning target is going to focus on that skill. So let's consider the first expression here. Okay, consider the expression 6x squared plus 15x. It's right here. That's where I'm at right here. 6x squared plus 15x. So one way I start to teach this is I say, all right, I want to be able to factor this expression, meaning I want to take 6x squared and I want to get it to look like something we had in the beginning. Like I start with this thing right here. Well, I want to factor it and get it to look like that thing. So when I look at this problem, I want to get it to look like something where there's a number here and there's something after it. Like that's what I want it to look like, right? So one way to start doing that is to find the greatest common factor of each of them. And you'll get very good at this, but the way I start to do this is I'm going to take each term. So I'm going to take 6x squared, 15x. I'm going to write out all of the factors of them. So the number 6 right here, 6 can be written as 2 times 3. Those are the factors of 6, right? And then x and x, that's where it gets kind of weird. x squared and x squared can be written as x times x. So I've kind of completely factored this expression with 4 terms, okay? Then 15x I can write out as 3 times 5 times x, because there's only one x, right? Now, when I think of the greatest common factor between them, GCF, I can see they both have a 3, and I can see they both have an x when I look at this, which means that those are all the numbers they have in common, so those are all the factors they have in common. And it has to be the greatest because there's nothing else left, right? They don't have anything else in common. So now what I can do is say, all right, what is the GCF of this expression? Well, the GCF, they each have in common, they each have a 3x in common, right? They don't do 3 times 3 and x times x. No, they each have this 3x here and the 3x here. They each have that in common. Okay, so my GCF is 3x between these two expressions. Now, if I just gave you 6 and 15 here, don't write this down, but if I just said, hey guys, what's the GCF of 6 and 15? I bet you'd all be able to come up with 3. Well, that's the same way I got the 3 here. So if you can do that in your head, awesome. You don't need to write all this stuff out. Okay, I'm just trying to give you a tool, a strategy here. Okay. The next step is once you have the GCF, now we're going to take that 3x, okay, and now we're going to think about what has to be inside here to get an answer of 6x squared plus 15x. There's 2 ways you can do this. One way that a lot of students like to do, but it is extremely time consuming, is that you look back here, see at 6x squared, what's left over? A 2 and an x, so you'd put a 2x here. Then look at what's left over here. It's a 5, so that's what goes in there, 2x and a 5. Okay, that's one way to think about it. And this does work because if I check it, if I go and distribute it, I do get 6x squared plus 15x. Okay, now I don't want this answer. This is my answer that I want. That's my answer, right? That is now factored. I've taken this expression and I've factored it into this thing. If we go back to the first page, see how that's very similar to this? I start with this guy, and so I've turned it into a multiplication problem. I've taken an addition problem, made it a multiplication problem. That's the heart of factoring here, okay? Now, let's think about it in a different way, right? What if I didn't have my leftover? What if I know my GCF is 3x and I want to know what's in here? Well, ask yourself, what has to go here? If 3x is here, what has to go here to get a 6x squared? Well, it has to be a 2, because 2 times 3 is 6, and I have to have an x to get the x squared. Additionally, what would have to go here to get a 15x times 3? Like, if I have 3x here, what has to go here to get 15x? Well, it has to be a 5. Like, this is logically thinking of what has to be left over. If I know that my GCF is 3x, what has to be left over to go inside? Okay, I prefer this second way better. It's less confusing to me, but again, the more you do this, the more you'll get a feel for it. Okay. So we've got these 2 expressions. We've got 6x squared plus 15x, and this is not something I'm ever going to ask you to do. But what I want to do is I want to say, hey, look, how do I know these 2 things are equivalent? Am I sure that they're the same? I mean, we can see that they're the same based on what I've taught you, but let's just double check. So it wants me to take this x equals 2, and it wants me to replace that in all of these expressions to see if we get the same answer. So let's do that. Let's put, okay, so this would be 12 plus 30 to give me 42. And here I'm going to have 6 times 4 plus 5. 6 times 9 to get 54. I have done some sort of math incorrectly. What have I done wrong? Oh, I know what I did wrong. See, I'm not going to pause this and undo this, because I knew I did something wrong, because I know that these 2 things are right. Okay, but when I go back here and look at my work, look what I did here. See how I forgot the squared up there? Alright, well now I got to erase. This is why we do work in pencil. Alright, let's see if I can get this right this time. Alright, so now I'm going to have 6 times 4, because 2 squared is 4 plus 30. 24 plus 30, there we go, 54. Okay, cool. So they do work once you put the right numbers down, okay? So let's do some more practice with this idea, okay? So I'm gonna do like, I don't know, I'll do like A, E, and F or something, and you can try a few on your own. So, exercise 2. For each of the following sets of monomials, we're just gonna find the GCF. Okay. So, you know, when you get this, I'll show you both ways. One way I do it and one way you can do it. You're going to notice that one way takes a really long time. So the way that I did it in the other one is, you know, listing out these factors, like, you know, 2 times 3 times x times x times x, and then here we've got 2 times 3 times 3 times x, right? And then circle what's the same. So I got that my GCF here is 6x. Okay, now, could you have done that by just looking at the 12 and the 18? What's the GCF of 12 and 18? It's 6. And then the way to do that with the x's is, do you see how there's only one x here? I'll do a different color. See how there's only one x here but 3 x's here? You take the smallest x. So they only each have one x in common, so that becomes my GCF. Now if this had said like x squared right here, then I would have put x squared. Okay? So I do it in my head, but I'm going to show you that method to just help you if you need it. Okay? Let's go ahead and do letter C together. So what is the GCF of 21 and 14? That's 7. And then I've got x squared. I'll use a different color here. I've got x squared and I've got x. Well, the lowest one of those is just x. And then my, my y's, I've got a y to the 5th and y to the 7th. My smallest one is the 5th, so this is my GCF. Now, it's important to read directions. This directions is only saying find the GCF. It's not saying factor completely. Okay, so I'm just looking for the GCF and then I'm done. And then I will do this one right here. Now, I know this guy has a negative. Don't worry about the negative. Okay, the negative doesn't matter because the negative is not a factor of each of them. The negative here, and I'm looking at E right now, the negative of this one is only a factor of the 12. So it's not going to be part of your common factor in your answer. Only the 12 has it. Now, if each of them was negative, then absolutely it would be part of it, but they're not all negative. So let's first start with the numbers. Between 20, 12, and 28, the GCF, I'm going to try 12 first because that's maybe the highest, but nope, 12 isn't going to 20. And then 6, because 6 is the next highest number that goes into 12. 6 doesn't go into 20 or 28. How about 4? Yep, 4 goes into all three, so that's got to be my GCF for the number. And then I'm going to do my x's here. So I have x to the 3rd, x squared, and x. So that means that just x is my GCF. So what I want you to do now is I want you to try and find the GCFs of D, B, and F. So pause the video, try and get those solutions, and then unpause when you're done. Again, if you don't get these right and you don't come ask for help, you know what I'm going to say when you want help on the practice, and it won't be good. So pause, try them on your own. Alright, here are the answers. B, you should have gotten 5x squared, D, 8x, and F, 9xy. If you did not, please come talk to me. I'll be happy to help you out. Okay. So now that we know how to find the GCF, now we're going to find the GCF and then our whatever factor we have left over, excuse me. Okay, so the first step is we got to look for a GCF. So in letter A, I'm going to see the GCF between 6x squared and 10x. So between 6 and 10, I think that is a 2 because 3 doesn't go into 10. So my GCF between 6 and 10 is 2, and then between x squared and x, it's going to be x. Now I put my parentheses because I'm now pulling out that 2x, and to get back the 6x squared and the 10x, I have to figure out what to multiply by that factor to get back. Well, to get back to a 6, I have to put a 3, and to get back to x squared, I have to put an x here. Then I'm going to put a plus sign, right, because there's a plus sign here. To get back into a 10x, this has to be a 5. So now I've factored this expression. And let me be really clear on one other point. This guy right here is called a factor. And this guy right here is also called a factor. And I can illustrate that a little bit by saying, look, 2 times 3 is 6, right? Well, isn't 2 a factor? And isn't 3 also a factor? I know that this doesn't look like a multiplication, this thing in green. I know that when you guys see this green thing I've written down, it's not a gut instinct to say that's a multiplication problem. But this set of parentheses right here, bumped up to this 2x, immediately I think multiplication. I know you see this plus sign and you think plus. But getting to an advanced level in math, you need to start seeing these things for that operation they are. That green thing is a multiplication problem. It's got 2 factors. It has a factor of 2x and it has a factor of 3x plus 5. When you multiply 2x times 3x plus 5, you get that original thing. Okay? We're going to talk more about that as we continue in the unit. Okay? I'm going to do a few more of these, and you're going to try the rest on your own as a you try. Okay? Let's take a look at letter E here. So now I've got 3 terms. I got to find the GCF of all 3. So between 2, 6, and 8, that's easy. That's a 2. And then x cubed, x squared, and x, that's an x. So I put that there, and now I got to figure out how to go back. So to get to a 6x to the third, I have to have a 3 here, and I've got to have an x squared here. That's the only way I'd get that 6x cubed. Now I've got to put a minus sign here, because there is a minus sign here with the 8. So it's got to be minus 4, because 2 times 4 is 8, and then it's got to be an x here to get the x squared. And then this is kind of tricky. This last thing, I'm saying, okay, wait, I have a 2x here, but I've already pulled out the 2x. So does that just mean I do this? No. Don't do what I just did. No, 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 no. You have to think about how you'd get a 2x back into the problem. You'd have to have a 1 here, right? Because as you're distributing the 2x to each thing, you've got to do 2x times 1 to get 2x. If you didn't have the 1 there, you wouldn't end up back with that original 2x right here. So whenever you have the same thing as the GCF in your original problem, it's a 1. Okay? And then how about I do, let's do G here. Okay? The GCF between all 3 with numbers is a 10. And then they don't have any letters in common. So this is just going to be x squared. This is going to be minus 4x. And this is going to be minus 5. Okay? No letters actually came out of that one. Okay? Go ahead and try the other 6 problems on your own, and then I will show you the answers. Okay, go ahead and pause. Okay, for B, I got 3 times x minus 8. C, 5x times 2x minus 3. D, 4 times x squared plus 2x plus 6. F, 5x squared times 2x minus 7. H, 2x squared times 4x squared minus 1, and finally I, 8x times x squared plus 3x minus 4. The last thing I want to leave you with is, and this will help you on tests this unit, because on this unit, your tests, there is no reason to get a wrong answer because you can always check your work. On this whole unit, you can always check your answers. And for this, if you want to check your answer, you just distribute and see if you get what you started with. Check by distributing. So for example, on this guy right here, is 2x squared times 4x squared 8x to the 4th? Yes. Distribute again. Is 2x squared times negative 1 negative 2x squared? Yes. Okay, then you've done it correctly. The one mistake students do on this a lot, and I'm going to highlight that in letter G. Okay, I'm going to go ahead and erase this answer real quick. Here's what a lot of students do, and I've seen this before, so be careful. They look at 10, 40, and 50, and they think, oh, they each have a 5 in it. So then your answer becomes 2x squared minus 8x minus 10. The problem with that is, yes, 5 is a factor, but is 5 the greatest factor? No. 5 is not, because look, if you look back at your stuff left over, 2, 8, and 10 still have a factor in common of a 2. So you want your greatest common factor, not just any factor. So I think that's where we're going to make some mistakes in this learning target, is that you guys might not find the greatest, you'll find just a factor. So be very careful with that. I want the greatest common factor, or you will get answers wrong, even though it does check correctly. It still will be wrong because it's not the greatest. Okay? Good luck on your practice, and always ask for help.